Let's see what we have today. Today we're going to deal with the electrostatics grade 10. So you can pause the video. And try the question out if you can. So before we move on, you can do me a favor by hitting the subscribe button and the thumb up. I will appreciate that. So let's get to the business. The question says, state the principle of conservation of charge in weights. So without the waste of time, the principle of charge, or the principle of conservation of charge, states that all the charges in the universe, they consist of an integer on one electron. So they consist of integer. So we call this the electron charge of -1,6 times 10 to the -19 coulomb. So the principle of conservation of charge, it states that all the charges in the universe, they consist of the integer of this number called electron charge on one electron. So we can just move to the next question. Two identical metal A and B sphere are a distance 6 centimeters apart, each on an isolated stand, carry initial charge of A positive 10 nanocoulomb and B negative 20 nanocoulomb respectively. The spheres are brought into contact and then separated again. So before you start calculating, once they mention that the spheres were brought into contact or are brought into contact and then they get separated, when they get separated, that means they form a new charge. So in other words, when the spheres are brought into contact, they form a new charge when they separate. So that means you will be expected to calculate a new charge. So we have sphere A and sphere B. Sphere A is positive 10 nanocoulomb. So B is negative 20 nanocoulomb. So before we go far, we must remember to convert. So this one is positive 10 nanocoulomb. So to convert it positive 10 nanocoulomb to coulomb, that means we must multiply, or let me say, we take 10 multiplied by 10 to the power -9. Then this one will be in coulomb. So nano 10 to the power -9. So the other one is -20 times 10 to the -9 coulomb. So that's how we convert the charge from nanocoulomb to coulomb. And then question A, it says, is there a force of attraction or repulsion? Then you explain your answer. So now we must check the spheres. The sphere A is carrying a positive charge, sphere B is carrying a negative charge. So positive and negative, these are unlike charges. So according to the principle of charge, all the charges that are unlike, or they are not the same when it comes to the signs. So unlike charges, they attract. Like charges, they repel. So here, since it's positive and negative, these are unlike charges. That means they must repel. So when they repel, we call that force between the spheres, we call that force the force of repulsion. So let's say A force of attraction or repulsion. That means this is the force of attraction. This is the force of attraction because these are unlike charges, so they must attract each other. So they said we must also explain the answer. So already I said that unlike charges attract. Unlike charges attract. So this is our reason. Then B, calculate the charge on each sphere after the spheres have separated. So the charge on each sphere, that is a new charge since they were brought into contact. So like I said, when they get separated, they form a new charge. So the charge on each sphere is a new charge. So B, we are expected to calculate a new charge. So we go to the formula sheet. When you go to the formula sheet, remember our topic is electrostatics. That means when you go to a formula sheet, you go straight to electrostatics. So this is the formula to calculate the number of electrons. This is the formula to calculate a new charge. So here we have our charge on electron, which is negative 1,6 times 10 to the negative 19 coulomb. So I've already mentioned that. So now since we are calculating a new charge, that means we are going to use this formula. Q, we can call it Q new as a new charge, is equals to Q1 plus Q2. Since we have two spheres, so we divide by 2. That means if there were 3, we're going to divide by 3. 4, we divide by 4, just like that. So sphere number 1 is 10. We converted this one already. 10 times 10 to the negative 9. So this one is 10 times 10 to the negative 9 plus the second sphere is negative 20. So it's negative 20 times 10 to the negative 9. Then we divide by 2. So the answer here is the charge on each sphere. So let's check. So when we add this with that one, then we divide by 2. The answer is going to be 5 times 10 to the negative 9 coulomb. So this is the charge on each sphere when they get separated after the contact. So question C, we calculated the number of electrons transferred from one sphere to another. So we go back to our formula sheet. So check under electrostatics, we only have 2 formulas, the new charge and the electron. So now the question said we must calculate the number of electrons transferred. So to calculate the number of electrons, that means we must deal with the formula with electrons on it. So the formula says N is equals to Q over, can call it QE. So this is the charge on electron. And then it says we must calculate the number of electrons. So this is the number of electrons, this is the charge, and then this is the electron charge. So now what is the charge? Since we've calculated the new charge, that means now our focus is on a new charge. Once you calculate a new charge, all the questions that are following that equation, they are based on a new charge. So we ignore all the charges that were given up there, then we focus on a new charge now. So the new charge is negative 5 times 10 to the negative 19. So this is negative 5 times 10 to the negative 9, sorry, not 19, divide Then the electron charge, we said, is negative 1,6 times 10 to the negative 19. So it's negative 1,6 times 10 to the negative 19. Then when we check, this is the answer, 3,125 times 10 to the power 10. So this is the number of electrons. That means 3,125 times 10 to the power 10 is electrons. So this is the answer for C, the number of electrons. So remember, this is the number. So there is no unit number of electrons, it's just that number electrons. So that's how we approach these questions. So remember, it's electrostatics grade 10. The only formulas that we have, there are only two formulas: the new charge and the electron charge. So those are only two formulas that are used in electrostatics in grade 10. So thank you very much for watching, and please don't forget to subscribe. Bye.